Alright, let's start routing. Before we jump in, let's do a quick analysis of the board. This PCB mainly has two types of traces, signal lines and power lines. We're not dealing with any high-speed signals or anything that needs special treatment, just basic signal and power lines. So here's the question, which one matters more, signal lines or power lines? Well, for this board, I can't tell you just straight up. Power lines are more important. Why? Because servo draws a lot of current. One servo can easily pull 200 to 250 mA. If you have 4 of them running, that's over an amp. That's a lot. If your power traces are too thin, your servos might lag or not move properly at all. So yeah, we've got to take power routing seriously. Signal lines? Not so much. As long as they connect properly, that's good enough. Let's look at the default trace width, 0.254 millimeters or 10 mils. That's okay for signal lines, but definitely too thin for power. So we'll go into the design and go into design rule and update a few things. In safe spacing, set the track from 4 to 6 mils for a bit more safety. The default wire width is 10 mils. Again, fine for signal. Now let's create a custom rule for power lines. Call it PWR. For this one, we'll use 20 mils for width and clearance. That should handle up to 1A of current without any issue. Apply this rule to all of the relevant nets. 3.3 volt, 5 volt, VBAT, thin, and G&D. Everything else, your signal lines, can stay at the default 10 mils. Then click apply and confirm. We're good to go. Now we can start routing. Choose the single track routing tool. On my system, the shortcut key is W, but on yours, it might be Alt and W. Signal lines are pretty straightforward. Just connect the pins. If something doesn't route cleanly, don't be afraid to delete the track and move components around to make things a bit neater. When routing power lines, you'll notice they automatically use the wider trace. That's because we just set that rule. Avoid 90-degree angles if you can. But if you do have some sharp corners, we can clean those up later with teardrop. When routing, there are a few general principles to follow. Try to finish routing on a single layer if possible, usually the top layer. Starting by routing the shorter line first, then move on to the longer connections. Even though power lines are more important, we usually route signal lines first. They're easier to get out of the way. If a signal or power line can't be routed cleanly on the top layer, no problem. You can use vias to drop down the bottom layer. Just double-click to place a via or add it manually if needed. Make sure you give yourself enough clearance. If a via throws a DRC, which is the design root check error, just nudge it over a bit. The trick is to stay flexible, adjust component placement and trace path as needed. There's no absolute correct way to route things. Just find what works best for your layout. After a while, things can get messy. Take some time to clean up your traces. Try to make your routes straight and evenly spaced. Align vias whenever possible. It looks like cleaner and more professional. Delete any stray or unnecessary segments. Even though this part is a bit tedious, a clean layout helps with manufacturing and troubleshooting later. Let's finish routing the power lines. Starting with 5V, VBAT, and 3.3V nets. For 5V, if the route is clear, just go ahead and connect it. If not, use VS to hop on the bottom layer. For tricky areas, like where a capacitor is blocking a path, feel free to move components around. Sometimes just shifting a resistor or capacitor can give you a room that you need it. Sometimes traces can get hard to see, especially if they are under silkscreen layers. So here's a tip. Hold Shift and S to toggle the layer visibility. This will dim the other layers and highlight just the top layer. Tap Shift and S again to cycle through visibility modes. This really helps when you are trying to see what's going on. When routing VBAT or VIN, again, don't hesitate to route on the bottom if the top is too congested. .3V lines tend to be the most numerous, and they're usually all over the board. You'll often need to route some on the top and others on the bottom. Don't stress if they don't look perfect. As long as they are functional and pass the DRC, you're good. Some people's boards just look better. It's all about taking that extra time to tidy up your layout. If a trace looks bad, just try another way. Shift it, reroute it, space it better, round out corners. The key is patience. PCB routing is kind of a grind, honestly. It's not super exciting, and one wrong move can mess things up. But once you get the hang of it, it becomes second nature, which will be easier. And with that, we're done with routing.